Okay, my name is Roy Li는, and I'm the founder of Ruff Chain. Today my topic is about the abstraction of the blockchain and the decentralized applications. The word abstraction is not mentioned frequently in the blockchain industry. It was mostly used in the old school technologies. However, I believe that the abstraction is more important than anything if you want to build a developer's ecosystem. When we talk about blockchain, we always talk about the consensus mechanism. We talk about the encryptions. We talk about the security. We talk about the P2P network, the block, the storage, any like decentralized distributional systems. And however, I mean, not only just the blockchain, like AI, like the other technologies, they all face the same problem. That how do we analyze one of the problem? For example, what is abstraction and why we need abstraction to all those problems? For instance, if you're facing a mathematical problem, let's say if you have a mathematical problem, and the first thing you need is a formula, consists of the decimal digits and the operators. This is the abstraction. And for the desktop applications, the first thing as a developer, the first thing you need is Windows. And Windows provides the abstraction to all the problems. And for cell phones, the cell phones needs the Android. Android gives you the abstraction, so you can program your applications on different types of cell phones like Samsung, Xiaomi, Huawei, and they all support Android. That's why you're using the same abstraction. The abstraction of the mobile development is necessary for any applications. Same thing for blockchain and for Internet of Things. I'm going to show you an example. Because my Ruff Chain is focusing on the Internet of Things. Our concentration is the things. That's why I'm going to show you an example of the IoT cases. This is supposed to be a video. No, actually, too bad. I can really not show the video. Actually, this photo was shot on my desk, and it shows the LCD screen connect with the button and the sound sensor. If I snap the fingers, the LCD screen prints out something. And this can be connected to the internet. And you can take any record on blockchain. Later on, I'm going to explain why we need those data to be sent to the blockchain to make it legitimate. And here's the code for the, it's not the above example, it's code, example code for development using Ruff. On the left-hand side, you can see is the old school approach. The reason why I come with the idea of Ruff is that I've been in this business for over 15 years, and I found it extremely difficult for me to build an application on the edge computing for the IoT application. For example, I may have been struggling with the C code, the memory control, the process management. On the left-hand side, I found it extremely difficult for me to understand, even if I have 15 years more experience in this industry. And on the right-hand side is that after I created Ruff, after 4 years of work, I created Ruff with the abstraction and the JavaScript runtime on the edge computing nodes on their MCUs or the links-based gateways. We are able to use JavaScript code, just like writing the web pages, like writing any web pages. We're able to use JavaScript code to code towards the object-oriented, the hardware solutions. So the right-hand side is easier to understand, and this is easy for regular developer application level of developers, not in infrastructure level of the embedded system developers. And this technology is adopted by Microsoft, GE, Schneider, Baidu, and any other mainstream companies, especially in China. So abstraction made the development easy. In the IoT industry, the biggest problem is that the fragmentation. The same thing happened to the blockchain is that you have different protocols. Let's say you have different protocols. You have different drivers. You have different data types. And you want to communicate between all those applications or those devices or those nodes. The only thing you need is that you need abstraction that unifies all those things. Otherwise, the application development can be really hard. For instance, if you want to settle the balance between Neo, Quantum, and the Ethereum. Right now, it's extremely hard for you to do so because you cannot check consistent between those three chains. You have to make a unified data format and then do the settlement once you build a connection between all these three chains, and you collect the data read the balance, find the transaction. Like Quantum supports UTXO, so you have to find all the transactions, query all the transactions to make sure that you understand you can retrieve all the way backwards. So the fragmentation makes it extremely hard especially for the Internet of Things, for the IoT development, and for the blockchain. Here's an example, is a real example of commercial level example, how we managed to use blockchain, apply blockchain on an enterprise level model. This is on the left-hand side, you can see a power panel, solar power panel. It's pretty normal in China. And then all the roofs, especially in Shanghai or the cities in the east, the roofs are now applied with the power plants, solar power plants. But 1 million watts requires $1 million investment. So those plants the equipment makers or those property owners, sometimes they cannot afford that because they are very short in their cash flows. So they need to raise money from the people from the public, or they raise money towards the finance gateways, finance proxies. The problem for them is that, this is a typical example of SFX security. The problem for that is that how do you make your data legitimate? How do you guarantee that the yield, the power it generates, how much money you're making per day, how do you make sure that the data is not editable, it's legitimate, and it's stamped with a timestamp? Here comes the problem, and the only solution is to use blockchain. That's the easy solution. That's why we need that. But the problem for applying blockchain is that you have to read the data from different types of inverters. The meters, sometimes some meters, they are, in Korea might be, I don't know the suppliers. You may have like 5 or 6 suppliers with like 70, 80 types of models. And those inverters, they have different drivers, they have different instructions, there are signals. You have to read and all this stuff from the electronic engineering level. And there's no unified data format for that. And before you apply anything to the chain, you need to make sure that all the data collected, they have the same format. They have the same data type. And that's the abstraction you need. So for developers, the developers should not need to worry about how I read data from this type of inverter, from this type of meter. All I need is that I have the logic. I have to write the application that reflects our business logic instead of how this driver works, how the protocol works. Like it's from CAN bus, Modbus, or the industry Ethernet, whatever. So dev-friendly matters. The reason why Ethereum is getting so popular is that you can learn Ethereum coding and build your smart contract within 30 minutes. For an ordinary developer, that's the easiest. Think, what else you can do other than learning Ethereum? That's almost no other options. Ethereum creates the abstraction to the blockchain. The problem for Ethereum is that the EVM is still very lower end. It's not secure enough. I'm going to cover that topic later. Not only we need to provide the dev-friendly blockchain, and we don't want our mainnet to be blocked easily by CryptoKitties. It's like Ethereum. Sometimes you can be blocked, it can be jammed, and sometimes you paid lots of gas and still your transaction didn't go through. So scalability is an issue. Even the Vitalik said that, okay, the sharding might be an option for the next few years for him to increase his scalability. The non-usual way to do this is I would call this a parallel execution of the smart contracts. For UTXO, like Quantum or Bitcoins, the transaction, to process all the transactions, it could be easy because transactions, order doesn't matter for most cases. other than you have to check the balance, right? So I can pay like $100 and pay another $50. So I can pay $50 first, $100 later, or I pay $100 first or $50 later. Order doesn't matter. But for contracts, if you want to change the status, so you maintain the global status, you want to change the status, you may find dependency issues. So one contract before it executes, it may require another contract to execute first. That may block you from parallel execution. So for example, in Ethereum, right? If you divide them into like 300 threads for 300 transactions, some transactions may require another contract that might be unfreeze this account in order to be able to allow this account to make transactions. So that one must execute first, and this one execute later. And sometimes we're talking about atomic operations. What is atomic operation? Atomic operation means that, let's say if I pay you $100, so my balance will deduct $100, subtract $100, and your balance will increase $100. And these two operations, they need to be executed. Either both of them gets executed, or neither of them gets executed. It cannot be like, okay, my balance lost $100. Okay, the network gets blocked or whatever, and the rest of this and the balance, the adding $100 on your balance didn't go through. So this is not going to happen. So this is a consistency issue. So atomic operations, like either you execute both contracts, or you execute none of them. So atomic operation in the parallel execution could be a pain. Because sometimes you want to execute those two commands simultaneously in the same time. But one command may fail, and that command may get through. And now when you merge together, you find, okay, there's a conflict between the atomic operations. And that could be an issue. But right now, people are trying to resolve this. I mean, for EOS tried that. I mean, I don't know how many of you actually read the white paper of EOS. Okay, I read EOS white paper at least 8 times. I went through the 8 times. I found an interesting part of the EOS white paper is that EOS encourages miners, I mean, there are supernodes, they're miners, to pack all the blocks in order. So packed in a certain order that matters, that's more favorable than, that's more favorable to be able to execute more parallel friendly. And then it provides a reward. Let's say if this contract, the way you pack this contract is more friendly to execute, it within like 10, 20 threads, then you get more reward. And this is how Ethereum did that. But alternatively, what we did is that we try to merge and we try to find the conflicts. Sometimes the conflicts comes from atomic operations from the same account, then there's not much we can do, or something that we need to figure out when merging. And sometimes the conflicts comes from the address. Sometimes the conflicts from the storage, and storage is not too much we can do because it's non-structural operations. That's the one alternative solution for that. So if you look at people telling you that, okay, what kind of a TPS we're trying to achieve, don't just believe that. Sometimes they just use big blocks, use huge blocks, and then it doesn't guarantee you that the performance you need. Sometimes you need not more than that, like parallel execution. If your execution cannot, if the contract can. It's not able to, you're not able to execute, to apply any parallel execution. You can't pack too much gas. Like you can pack like 5 million gas per block. You cannot pack like 10 million, 20 million, 50 million gases. So that's the parallel execution issue. And for optimization, the optimization part is that Ethereum is getting 500 gigs of its global status, it's tree. And 500 gigs is not a small number. Remember that it's still growing. For Ethereum, it's still growing. The problem for that is, it's wasting. It's not just about storage. 500 gigs is okay. If you use SSD, it's still fine. It's not too much too big issue or what. But the problem is the read and write. You cannot put 500 gigs in memory, right? So if you cannot put this into memory, so how do you accelerate the read and writes, the I/O, the read and writes? Remember that memories read writes 1,000 times faster than the hard drives. How do you do this? And the LevelDB provide you with normally most of chance you are using LevelDB. We're gonna change LevelDB to something else, but it's not yet to release. It's yet to be released. LevelDB gives you the ability for sequential read and writing. So if you read write sequentially, then you may skip a lot of the read writes, a lot of prerequisites. So it will help you read like 100 times faster than usual. But sometimes it's not just about sequential read and writes. You have to find a way to apply this on the random read and writing. So this could be another issue. For us, it's like we managed to substitute LevelDB to the alternative solutions so that the sequential read and writing can be 10 times better, and the random read and writes can be like 100, 500 times better. Okay, I got 1 minute, I know that. So the hierarchy for this, in conclusion, the hierarchy for this is that infrastructure level developers should focus on storage. For example, storage. How do you make this read and writes faster? Or how you make your change rule consensus mechanism so that you may be more decentralized and more secure. And how do you make it for security? I think I mentioned the SPV. Oh, sorry, I forgot to mention the SPV. For SPV, how do you, if the SPV node does not store all the block information, what kind of necessary information does it require to make sure that there's no fraud, compact fraud, so it's fraud proof? Bitcoin managed to do that, but not for the Ethereum. That's why the SPV for Ethereum sometimes can be tricky, and Bitcoin was definitely, even if in Bitcoin 140, in BIP 141, Bitcoin managed to prove that it's a compact fraud proof. And for the SDK, that's the part that I think it matters. So for application developers, on the very upper level application developers, they should only focus on their business logics. You may use our libraries, our utilities, our SDKs, our APIs. So you don't have to worry about that, how the performance may go up, or how do you store the data, how do you structure your global status, and how you're synchronized between all those nodes. So these are not supposed to be the question that the developers need. And believe it or not, the past few years has been the years for the computer scientists who come up with the algorithms. The P2P network method, the blockchain, the database design, the KV, the Merkle trees, the Merkle-Patricia trees, those scientists. But the next few years will be the years for the engineers. Those engineers will fulfill your dreams. They will apply this. They will come with your creativity. They will put your creativity into the real actions. They'll be able to develop those decentralized applications based on the infrastructure you have provided them. So the next years will be the years of engineers. So be nice to those engineers like me, and your future depends on them. Okay, that's my topic. Thanks.